The Qualco process begins on the farm with the primary feedstock for the digester, manure. For dairy farms, manure is often viewed as a problem, but Qualco offered Andy Werkhoven a way to turn that around.
It's not a waste, it's a value. Anytime you can take a waste stream and turn it into a value stream, you've done something extremely positive.
Werkhoven has taken on the day-to-day management of Qualco operations and shows us how the whole process works.
This is a typical freestall barn where our cows live. Our cows are bedded in sand, which is the ideal bedding of choice because it's inorganic, and sand is extremely soft and doesn't compact and very comfortable, so your cows are happy and healthy in it. This is what they look like after the cows just came back from their going to the parlor. We say we do housekeeping for them. As soon as a cow goes into the parlor, which she does 3 times a day to give us her milk, we come in here and we clean their stalls out and we flush out their barns. We feed our cows a total mixed ration. It's made of alfalfa hay, corn silage, and corn, just some grain corns, but these are the classic ingredients that go into dairy cow feed. We're taking a product and we're first getting the milk out of it, and after you get the milk out of it, you try to get the electricity out of it and the fertilizer out of it. As soon as the cows are all removed, they'll wash down the floors. So as you see right now, the floors are actually quite dirty. This will all get flushed down here as soon as the cows are out.
This method of dairy operation allows Werkhoven to capture the manure efficiently, but there are several important steps before it's sent to the digester.
So here's where the manure comes out of the back end of the dairy, and it goes into this here big round circle, which is a cone shape. All the sand settles out here, and then an auger removes all the sand out the end. And the manure in the water is flowing by where it's going to go into the next process. After the manure, we've taken the sand out. It's pumped over these separators where the solids are screened out and dropped into our sending tank. And the liquid portion flows through the back side here, back up into our clarifier, where we'll clean it up some more, keeping the clean water back to reflush in the barns, and adding the dirty water to the solid portion that we just cleaned out, and that will get sent off to the digester. Behind me is our send tank, or for a lack of better description, our toilet, which when it's full, this pump turns on and sends the manure 1.5 miles down the road to our digester. This is where all the manure from our dairy comes and is blended with every other product that comes here. And they could be as varied as cheese whey, to past pull date beverages, to cattle blood, to restaurant grease, or fish waste, or waste pulp from a pulp plant. That all comes here and stirred up and blended to make the perfect blend to feed the bugs inside of our digester.
The mixture from the receiving pit is pumped into the anaerobic digester, 188 feet long, 74 feet wide, with a capacity of 1,452,000 gallons. It's kept at a constant 100 degrees by waste heat from the generator. Some of the methane generated by the microbes is pumped back through the digester to agitate the mixture and maximize production of gas.
This is a big box that's all insulated and is filled with all the slurry that you just seen in our mixing pit.
80,000 gallons per day is pumped into the digester from the reception pit and takes 17 days to go through the digestion process.
It's a flow-through system, so every day some comes in and some goes out, and it basically is the heart of the system. It's where all the gas is created that runs our generators. Now we're inside the building where all the gas comes. It first goes to a pump that recirculates it back into the digester to the different zones to agitate it and to create more gas. The second pump actually chills the gas, and from the chiller, it takes the condensation out, it goes to a filter, and from the filter, it goes all the way across to the engine where it is being burned in a motor that's modified to run on straight biogas. The motor turns a large generator, which is sending electricity out to the grid, and at the same time, it's producing 1,000-degree exhaust that goes through this tank and creates a bunch of hot water. That hot water is in turn returned to the digester to keep it at 100 degrees. Right now, our engine is burning 145 CFM of gas, and we actually have over 400 going out the flare, which means we have just some really highly productive bacteria in there working. Our challenge then at Qualco is to get another generator online to harvest that excess energy. We produce 450 kW steady state here, 24/7, which is one of the joys of a manure-based biogas system, is it goes 365 days out of the year.
Joe Harrison is a nutrient management specialist with Washington State University and has worked closely with Qualco to design and test the effectiveness of its systems.
We're doing a better job of reconnecting this broken nutrient cycle that we have, and so we can actually do a better job of fertilizing the land or fertilizing the crops to grow crops to feed the cows and get better land utilization, then which feeds back to better stewardship and a better use of this valuable land we have here in western Washington.
Harrison explains what happens after the material leaves the digester.
We're going to come over and look at the first part of this unit that separates the liquid from the solids. What we're trying to do is take out the large particles in particular. A lot of the very small suspended solids will stay in with the liquid stream that goes to the lagoon for further use as fertilizer. But in here we have a rotating drum. It's perforated on the outside. On the inside of this drum there is a ribbon that then helps bring the manure from the far end up to this end, where then the material, the solids, are dropped into an auger here. Then it's dropped through these roller presses. And once it goes through this system, it drops down to the concrete floor below and then is transported over to the compost facility to be put into rotating drums for composting.
Over here is where we take the solids that are coming out from the digester and we actually convert from an anaerobic process to an aerobic process. These are in-vessel composters where natural aerobic bacteria go to work on those solids and break the product down even further and sterilize it just by being at over 140 degrees for the 3 days as they pass through these drums.
Harrison continues the story with the liquid portion.
We're now at the last point that the liquid is handled before it is transferred out to the lagoons. So it comes through this pipe after the liquid solid separator, goes through this flume, and this looks kind of sophisticated. The reason for that is this is engineered so that through this tube here we have bubbles going in there, then that reads into a system here that tells us the flow rate. So we're monitoring this flow 24 hours a day, 7 days a week, 365 days a year. Material then drops into what we call our transfer tank. It's basically a septic tank. From here, the pumps that are mounted through the shafts here then pump the material on out to the lagoons. We've now reached anaerobic digester lagoons where the effluent from the anaerobic digestion process is stored. Then during the growing season, the material is pumped with a large pump and underground main lines and then connected either into big guns that spray the material out on the field, or in the early part of the year, what they'll do is they'll actually use an injector and inject manure into the ground about this deep.
This is the end of the line where the finished product comes off, and this is the product that we use on our fields to grow some great crops. So we've gotten the milk out of it, then we take the electricity out of it, we remove the odor from it, and leave just the right amount of nitrogen, potassium, and phosphorus in it here so it's ready to grow the next season's crop to do it all over again.